we have to access them, so we program some codes.
Yes. So only storing is not enough. After storing this thing, we have to access it. And in the program, it is very easy because in the program, everything is stored in the RAM. Okay, whenever you are running something ABCD, int ABC, I have declared. So int ABC is in the, okay, I just open one Word file, it will be easier for you. No, I just open up Paint. Okay, what we do there, A, okay. So for A, what we have to do, whenever we are writing int a memory will be allocated there. And if we say that we have to write something, we suppose we want to write 20 for it. So A equals to 20. Where it will store?
The RAM.
In the RAM. But in which memory location? We don't know, isn't it?
Ma'am, dynamic memory.
Uh, any address, suppose this is the address 100. Okay, the address of this array is, variable A is 100. So for how we can access A, the information about A, where we can get it?
Using the
Value
pointers.
at address space.
Value in that memory address. So I have to, if it is my memory location 0, 1, 2, like that. So I have to, after that I have to move here when this is the 100 location. Okay, and in that 100 location actually the value 20 will be saved. Clear? Up to this clear? A equals to, when we talked about int A, basically a variable A will be created in which location, suppose in 100 location. So in that memory I can get the value. Up to this clear?
Yes, ma'am.
Yes, ma'am.
Okay. Now I need to, if I want to access this A information, what information I require? 20, or in which memory location it is?
The memory address.
Memory address 100. So as it is not in the RAM, in the hard disk, I have to record one file where I have to put, if I want to access A, I have to go to 100, isn't it? Then only in the next step time when we can open that 100 location, I can go and get 20, the information about A. Yes or no?
Yes, ma'am.
So that file is called the internal schema. In that file where the information about a student means your name is, the name is Saurabh. So I have to put that Saurabh in some memory location. So in that memory location is written in some file. Means if I go to that location, I can go at the information about the Saurabh record. Okay, a file maintain that thing. That is the internal schema or physical schema. Clear?
Yes, ma'am.
Any confusion?
No, ma'am.
Now it is clear?
Yes, ma'am.
Okay. Now some other files are there. Okay, where only it will fetch the information, and you can watch a table where the table names are there and these are the value are available. Okay, that thing is written, not all the values. How it will be looks like, that is there. How that it will show that the column name will be written this way. A file is there where it will be written, column names will be written this way, all the values will be one by one separated by, and the information about the next entity will be put there, next entity in this way. Okay, a file is there which maintain this information only, that how the data will be visible to a user. Clear? That is the external schema. Okay, how your file looks like to the external user, that is called the external schema. These two I think clear now. How your file will be looks like. It will be looks like a table. Means it will be shown like that. Okay, this is the order table. It will be shown like that. So it is called the external view. A file is there which maintain this thing. Is the external view, external file is clear? A file where it is written how your data will be visible to the user. Okay?
Okay, ma'am.
I think external schema is the easiest one. Then how your files will be looks like to the external user or the user of the system, it is the external schema. Now the different thing is the, or different file is the conceptual schema. Conceptual schema is a file which is put in the, if we go, it's there, this is your hard disk. Okay, in the hard disk you have the data files, means the raw data. I told you the information about name of the students, roll number, everything is stored in some file, and it is written in the internal schema. So this is the information about where your data is, from where it is started up to where it is there. That is the internal schema. And what your user or application user, India user will view, that is written some file, that is the external schema. And in between these two is those who are, that query optimizer will ask that I need this information, I need that information. So which information will be bring from the hard disk to main memory, or how actually the data is stored. Okay, one thing, in the hard disk, the data will be stored in which format? Tell me. In computer, in which format data will be stored?
Binary data.
Yes, 0 and 1 format. Okay. Now, which will be converted into integer and which will be converted will be text. In the C file, who will decide this thing? At the time of declaration, we declare this thing, isn't it? Int A, int B, char C, double D, isn't it? Anyone have any confusion? If you do not communicate, how can I know if you are understanding or not?
No, ma'am.
Yes, ma'am, it's clear.
Now tell me, so data is saved in the hard disk 0 and 1 bytes. Okay. Now, which will be converted in the string and which will be converted into the integer. Means when you are reading, it will be a string, it will be an integer. Somewhere you have to write. Is yes or no?
Compiler will do the work.
Huh? Because in the hard disk, it is a bit string. Only 0 and 1, 0 and 1s are there. and internal schema, that's beginning address, end address is written. Okay, now you have to, after fetching this data, you will convert it in a string or you will convert it in an integer. What you will do? So definitely somewhere you have to write this thing, that after fetching this bit string, it will be converted into the integer, it will be converted into the string, it will be converted into the special character, isn't it?
And secondary schema will do that.
Yes, conceptual schema will do that. Now it is clear why we need 3 schema. Because if we put all the information in one file, it will be, if any changes will happen, you have to change all the information. But independency, I told you, given there means in the internal storage where your data is, and from the begin only the beginning address and end address. So if you change from one location to another location, only your internal files will be changed. That conceptual schema have the concept that after fetching this 0 and 1s, what I have to do? That is written in the conceptual schema. So you do not need to change the conceptual schema. That is one independency. Means if you changing your physical schema, you don't need to change the concept, because conceptual schema have the idea, after taking this huge bit string, I will put it in a string. I will use the means it will be converted in which domain. Okay, that is written in the conceptual schema. Means the roll number, it is a 10-digit integer. Name, it will be a 30-character string. So 30-character string. So this information will be stored in the 30-character strings. Clear? And external schema only show you this is your table. These are the information. Okay.
Yes, ma'am.
Yes, ma'am.
Now I think it becomes boring.
No, ma'am.
Now it's become boring. Very boring subject. Yes.
No, ma'am, it isn't.
No, it's not very boring. Actually, the online mode is boring. I also bored. Because whenever teacher is saying monotonically, you do not have to do anything. Okay. In the class, you can chatting with your friends. If you the teacher's lectures is not as per your expectation, you can chat with your friends, but here you can't do that. Okay. Now, is it clear, or any confusion is there up to this?
Clear.
Clear. Okay. Very good. Now, basically, I am creating the base for the SQL. That is, when you are storing this thing in the database, I told you the physical information or the conceptual schema where it will be changed in where. Okay. Similarly, for each of this part, different types of language is also there. It's only one language in the database we use, that is the SQL. Okay, but in SQL also some different part is there. Okay, for creating a file or deleting a file, we use the create command, delete command. These are called the data definition language. Okay. Some other things are there. Whenever you have the data, you want to fetch those things, that we call the data query language. Okay, only the select star from there. Okay, this type of languages are there. And for inserting some information, deleting some information, modifying some information, some other SQLs are there. That is called the okay. So these are 3 main category of the language of the DBMS, and those terms you can watch here. DDL, and for each of the language, compilers also required. DDL compiler, DML compiler, query optimizer. Okay, so you can fetch the data from the database. a DBA is there who will manage the whole database. That is the data administrator actually, and the short form is DBA, and it will actually design the whole database. Okay, the schema definition, storage structure, access methods, what will be the physical structure, where will be the authorization, means one user will capture all the files or only a particular file, or it can modify the whole records or not. Okay, so these are some permissions are there that you can do. For example, in the zooms, okay, zooms you can modify all the files, or only you watch only your marks only. Can you see the other students' marks in zooms?
No,
No,
ma'am.
ma'am.
Only with your user ID and password what you can access?
Ma'am, my mark.
Only your portion, yes, only your portion of data. That is actually the authorization. Yes, you have authorized only for that particular record. Only you can access your information only. Okay, so that will be permission given by the DBA, who is the database administrator. They will make this thing. And these are the some different types of user. Casual user, those who will occasionally go there. Okay, and naive user, those who are constantly working or updating the database. Those who are working in the casual user are for the Zooms you, or not only Zooms. If we go with the Gmail facility, okay, you are the casual user. You just put your user ID and password, and you open your data mailbox only. Okay, so you are the casual user there. But some peoples are employees who are working concurrently to checking, querying, updating, everything is working properly or not. They are the naive user. Okay, and some sophisticated users are there who will need this thing. Okay, implementation, and in this subject actually your role is this sophisticated user, that I will give you some query, you will write the answer in the SQL, or the complex way you will solve that requirements using a select query. So they are basically the sophisticated user. And some system analysts are there who actually think that how many tables will be there, which column will come under which tables. If the size of the table is larger, then you can break it into two tables. Okay, and application programmer are the different types of programmer. They will use the, for example, when you write a Java code or C code, and from there you are accessing the database. They are basically the application programmer. A database is there, but using that database you are writing your own application software. Okay, that's enough for now. Tell me if you have any question. Next day I will start SQL, or so should I start some part?
There are very few students. When all the we can start next.
Okay, that's good. Okay, one thing you do then installed a software, either MySQL. Okay, it is freely available. You can install MySQL.
Can you send the link in Google Classroom for me?
MySQL.
Yes, the link you said you'll send something in the Google Classroom.
Okay.
If you can do it, it will be very good. Thank you.
Anything else? Anyone have any query?
No, ma'am.
Okay, thank you then. If you, I already uploaded this slide in the classroom. Learn it. At least read once or two times. It will be clear that actually what is the structure of the database. Then it will be very easy for writing your SQL code. Okay. And next day I will start SQL.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you. All.
Thank you, ma'am.
Thank you, ma'am.